Welcome back to Hex and Cube map generation visual scripting using uNode Part 5. In Part 5 we're going to set up a get neighboring tile logic. We'll integrate some Leantween. We're using iEnumerator for a delay timer. We'll set up some properties, a Lambda, and then fix a few things. In this particular tutorial we're going to go ahead and work solely on the game tiles. So go ahead and in your hierarchy, we did create the game tiles earlier. Go ahead and click on the prefab or game object and use the editor to open it. What we're going to do is create a number of variables. The first one is a node model game object of type game object. The second one will be an auto run of a boolean. The next one will be a show nodes of boolean. Then we have a scale time that we'll need, a node scale to size, both of floats, so 2 more floats. We will need a game board object of type game manager. So it should be listed there as game manager, and we can call this game board. We'll need to pick up the object, the game board object, so we'll save it in that variable. Then we're going to go ahead and get a Leantween ease type for our integration of Leantween. We'll call this Leantween ease type. We need a list object of neighbor tiles. We'll use an M underscore neighboring tiles. Anything with a M underscore will be a property, and I'll show you how to set those up later. We'll need M underscore coordinates as a vector 2. Here's where we're going to set the properties. So in the properties area, go ahead and click the plus button, and we'll actually need 2 of them, but you can call one neighbor tiles, and the other one will be called coordinates, and they're going to have a getter, so we'll have to grab the getter as well. So let's go ahead and name these correctly. There we go. And then when you right click, you can select add getter, and so go ahead and right click on both of them and select add getter. Now we'll go ahead and add the methods or functions that we need. So go ahead and click on the plus button next to the functions, and we will set up at least 3 or 4 of these. One's going to be an iEnumerator, and a couple of other ones. So here we'll have show geometry. We can right click or double click on these, and if you're right clicking, select rename. This one will be find neighbors, and then the last one will be time delay, and this one will be the iEnumerator. So for the find neighbors, this will return a list of game objects and take in a list of game objects. So we want to select the plus button near the parameters, and what we're going to do is call this one game tiles, and then we're also going to get the return type at the top right hand corner of a list of game objects as well. So both the in parameter and the return type will be a list of game objects. And for the iEnumerator or the time delay, that will be a return type of iEnumerator. Then we'll go ahead and set the default values for some of the variables. So for the show nodes and auto run, we'll set those to true. Just check mark the box there. For the scale time, we'll use 0.25, and for the node scale to size, we'll use 1. For the Leantween ease type, you can select whatever you want, whatever you prefer the Leantween ease type to be, and then ease in is what I think I selected. Then we'll go ahead and set up or finish setting up the getter for neighbor tiles and coordinates. So go ahead and click on the getter for that, and then what we'll do is drag in the M neighbor tiles and select get, and then just drag it into the return type. We'll do exactly the same thing for the getter for the coordinates. We'll use mcoords, and we'll plug that into the return type pin, just like that. Alright, so now we're going to go ahead and just start with the start method, which is, I guess, a good place to start. And we're going to go ahead and get the game manager. So we want to drag in the game board, game object that we created just a bit ago. And we want to do a set. And then what we're going to do is do a find object of type. We're going to select that, and then we're going to find the type game manager. Select that, and then click the select button and connect the pins together. So that first one will get us the game board. There should only be one in our project, so, and in the scene that we're running, so this should be fine. We won't have multiple ones. So the next one is an if statement, and then we're basically going to say if you know it's null or not null, do something, right? So if it's not null, does not equal null, then it'll be true and we'll continue to do something. If it is null, i.e. it's not found, then we'll go ahead and create an error message to the log, or debug.log. So there we dragged in the game board game object does not equal null to the if, and then we'll get the, if it's false, then we'll do a debug.log, and you can type in whatever is good for you. I typically like putting error and then the method that the error is coming from so I can find it quickly. Next thing we're going to do is set the Leantween type, type, and the isShowNodes. I'm going to pull those values from the game board manager itself. So here we're going to go ahead and drag in and drop the set value for the Leantween type, or Ltween type, and go ahead and drag in the game board variable, get it, and then we're going to go ahead and get the Leantween type. And we'll plug the Leantween type pin into the set value pin. Next step is to connect in the isAutoRun and the isShowNodes, and we're going to do those identically to what we just did with the Leantween type. We're going to set that from the game board manager itself. So we're going to set isAutoRun, or AutoRun, and then we'll grab the game board and we'll find isAutoStart. Do the same thing with the show nodes, or isShowNodes. So we're going to go ahead and set that. I got a little ahead of myself with the setting the value of the node model game object, which we're going to go ahead and do next. So go ahead and drag in the node model geo game object and select set. We need to grab the game object.find with the string input value. There we go, that's the right one. And then off of this one, we're going to go ahead and do a string builder. And we're going to need 3 string values here. The middle one will be just a slash. And then what we're going to do is the top string 0 That'll be gametiles.name. You can get gametiles.name by pulling off from the string builder 0 pin, or you can just right click on the background, select add node, and type in gametiles.name. Either one should work. So if you can click on gametiles, name should be in the list here. There we are. Then you're going to go ahead and connect that pin to the pin 0 of the string builder, and then the instance of this is going to be this. This game object. And you just click continue. We don't need to do any conversion there. String 2 of the string builder will be this.transform.getChild game object, or game object.name. So here we're going to go ahead and grab the object.name. Then we're going to go ahead and from that grab the transform.getChild. And it's going to be the first one on the list because it's itself. It's actually not one. We'll have to come back and fix that later. The component.transform is an inherited member, so you'll need to select on uNode inherited member, and then find the component.transform. And that will be this as well. That was the right one. Must have. Oops. That's definitely not the right one. Let's try this one more time. Okay, this is finally got the right one. I think I was right the first time. That component.transform will be connected to this as well. Looks like I forgot to do that in the video, and I'll have to come back to that later. Now we're going to go ahead and drop in an if statement, and we're going to double check to make sure the node model game object is not null. If it is null, we will go ahead and do a debug.log error. Because if it can't find it, you know, basically itself, the node model game object, or the game object for the node, then there's a problem. So node model game object does not equal null. Plugs into the if statement, similar to what we did above. And if it's false, then we'll go ahead and do a debug.log. Now what we're going to do is set the local scale of the node model game object to a vector 3.0 or 000. So what we're going to do here is grab in the node model game object from the variables list. We're going to get it. And then what we're going to do is we're going to set the local scale, the transform.local scale. What I've found is that the easiest way to do that is right click on the canvas and select add node set, and then find the transform.local scale. That'll add both the set value and the node for transform.local scale. And in this particular case, we will want to convert, so click yes to convert, or click convert to agree. There we go. Now what we're going to do is make the vector 3 a vector 3.0. We'll go ahead and put an if statement in here. So if auto run is selected, then it will continue. If it's not, it will just stay there. I think we'll probably get rid of this later, but for now, it seems like a good idea. We'll probably refactor that a little bit later on. So go ahead and drop the auto run in to the if statement, and then what we'll do is, if true, we will run the show geometry method. Now we're going to go ahead and set the m coords, or m underscore coords. We're going to set that value, and basically it's going to be a new vector 2 for both the x and the z. So m coordinates equals a new vector 2 transform.position.x and transform.position.z. So we will go ahead and link in to the new vector 2 a current transform.position.vector 3.x. So we will need the vector 3.x and a vector 3.z for the x and y values. Let's see if I can find what I'm looking for here. Alright, there's the transform.position. We'll get the vector 3.x. There we go. Probably should have just typed in x to start with. Now we're basically going to do the same thing, but for the y, but it will be a vector 3.z instead. In either one of these instances, I did not connect in the get.trans or the component.transform on the instance pin. I just left it, and it does say this, but I notice in code it actually says base instead of this. In this particular instance, it didn't really seem to matter, but just be aware that your component.transform, even though it does say this there in the field, it's actually a base.transform, and so that may or may not make a difference depending on what you're dealing with in code. Now we'll go ahead and start the coroutine or the iEnumerator. So right click, add node, and select start coroutine, and then what we're going to do is drag in it needs to say this in the drop down for instance, and that might be the wrong start coroutine one. Yeah, it was the wrong one. Sorry about that. So make sure you grab the one that actually has the coroutine icon near it. Make sure you select this and then plug in the actual time delay iEnumerator into that pin. There we go. That looks good now. I guess it's a good time as any to go ahead and click on the time delay and flesh out what the iEnumerator will actually do. So what we're going to want to do is wait for seconds, and maybe we'll put in 0.2. We might want to modify that later to probably 1, but for now that's probably adequate. And then we'll go ahead and set our mNeighbor tiles. So we're going to go ahead and drag that in, do set value, and this will be game board tiles, and find neighbors, and that'll be a list of game objects. Easiest way to do this is to actually drag and drop the find neighbors method into there, because it does an input and a return value. So I had problems actually finding it in here. It didn't find it for some reason, but it is in this same C# script, right? So we should just be able to drag and drop it from the functions area there, just like that. Just notice here that the find neighbors method does have a return type and a parameters, right? Those are listed up here in the right hand corner under return type and parameters. That enables this method here to have an input and output. Cool, that finishes up the time delay iEnumerator. We will be back to add some more stuff in here later, but let's go ahead and continue with the show geometry method, and we will start working on the initial components of the show geometry. In here, what we want to do is check to see if we're supposed to show the nodes. That's the whole point of showing geometry in this particular case on the game tiles game object, right? So we'll drag in an if statement, and then we'll do show nodes, just like that. If that's true, then we will want to enable the mesh renderer. If it's false, we will disable the mesh renderer. And then we'll continue on using the finish after that. So here we'll go ahead and get the node model game object, and then we'll get the get component mesh render of that object. That is definitely not the right one. Get component mesh render dot get component mesh render. It's doubled, and I've seen this before. I somehow clicked too many options in there, so I'll have to come back and get that. But we do want the mesh render dot enable. That is correct, but we'll need to do the set node on that as well. So add set node, or add node set, and then grab the mesh render dot enable. There we go. Now we can actually set that. Get rid of that one. And that is not looking correct, but I guess we'll come back to that potentially, because that's too many get components in that list there. Nevertheless, let's move on, and we will we set that boolean there, and we can go ahead and if we select boolean in the drop down, we can go ahead and enable or disable it by clicking the check mark. We're going to go ahead and copy and paste this. That's the quickest way, because the only thing that changes is that check mark, right? So now we will turn that check mark off, and now we're done with that if statement. After the if statement, we will have another if statement. We want to make sure, again, to make sure that and maybe this is just too much checking, but again, we'll do some double checking to make sure the node model game object is not null. So we'll throw in another if statement here, similar to what we did in some of the other areas, and make sure that it's not equal to null. If it's false, we will do a debug.log indicating that there's a problem. If it's true, then we will set up a Leantween ease type. Alright, here's our debug.log, and we can go ahead and type in any message you so desire, something that makes sense to you. In my particular case, error in show geometry, game object missing, or something like that might work. On the true side of the if statement, we are going to set the Leantween ease type. So in this particular case, we will draw down from the true and select ltdscr.setEase. And we want to make sure we select the one that has an ease type as an input value. Just like that. And then what we're going to do is drag and get our variable that we made and plug it right into the ease type, because that's kind of the global variable that we'll use to define that. Now what we're going to do is get the instance for that. So we are going to use node scale to size, and we're going to do a new vector 3, and we'll just set, it's basically going to grow and grow the objects over time. So we're going to grow the entire object, so both the x and z values will be grown over time. I'm not sure about the y. That will probably be grown as well, but we can play with that at a later time. And then we are going to do a leantween.scale, and that will be for the node model game object. So that's the game object that we're going to be putting here, and the scale time will drag in from the global variables and select it as the time value. And that's how we use Leantween, or really any tween package, to integrate with uNode. Pretty straightforward. Alright, now that that's completed, we will go ahead and continue with the next method, find neighbors. So go ahead and click on the find neighbors method, and we will start that. This is not an overly complicated, or I should say it's not an overly long method to do, but it is a little bit complicated because we use a Lambda function. So first thing we're going to go ahead and set up here is the for each loop, and that will use the game board and the game manager.directions function to feed into the for loop. So it basically takes in the directions and goes through each of those directions. We will have a return, because there is a return type here, and we do need to create a couple of local variables. The first one is going to be a game object, and we'll call this one found neighbor. This will identify the neighbors, the neighbor found. And then we're going to need another one, and this will be a list of game objects, and we'll call this one nList, or neighbors list. So the return value of this method will be the nList. So what we're going to do is get that game board I mentioned earlier, get that value, and then we'll get the directions and feed that through the for loop. The for each loop will go through each of the directions as defined in the game manager.directions method. So we're going to grab that local variable we just created and set that, connect that to the body of the for each loop, and this is where we're going to kind of work on the Lambda function will be a part of this statement here. So it took me a while to figure this one out, but what we're going to do is add a node game tiles. And we're going to plug that game tiles in a list of game objects find. So once we have the list of list.find, or the find under the list option, we'll go ahead and plug all of these in. The game tiles to list game object.find. And we'll set that value find neighbor, just like this. So on this list.find, there's a match. If you right-click on that pin, you can assign a lambda. This took me a while to figure out, but that's how you get the lambda function there. You don't drag and drop it in, but you right-click and select it. Honestly, I probably can't even describe how this Lambda function works, so if you just watch how I construct it, that'll probably help you the most. Sorry. Not that familiar with these Lambda functions, so sorry about that. So the coordinates will be plugged into the bottom port pin of the add, and we'll just convert if possible. Maybe that didn't work, but we might want to not convert if possible. Sometimes that a little red mark comes up. If you just drag it, notice this was previously a float add. So what I found, if we add a new one in and then just drag it in and continue, it automatically converts that that pin type. I've had little problems with the pin type, but if we drag the index or value of the for loop to that add and then just continue, it then converts the output to a vector, and that seems to work. The P0 of the Lambda goes to the instance pin of the GameObject.get component of game tiles. So that's the GameObject.get component of type game tiles, and we'll put the P0 output of the Lambda to the input of or instances of that. And then that output goes to the GameTiles.coordinates. Notice we still have an explanation mark there. So I'm just going to redo this, not found. Sometimes it doesn't reset the pin values if they aren't the input values are not set up correctly on the input side. Sometimes it does freak out, and you have to kind of remove it and just re-add it with the input values first and then the output value. Notice here I swap out the not equals with an equals statement, and we're going to plug in the input values of that first, so it then changes the output value. We still have that mark. It will go away. I just have to I see the add there is not. Notice how it has the string component there, so that's incorrect. We can maybe either reset it or just add a new one, which I found to be the easiest. Just create a new one and then plug in the input values first, as I was mentioning, and then it should convert that output value to what we need. And there, the mark goes away, and that's the way it needs to be set up. A bit frustrating, but it is what it is. Easier than typing it out, in my opinion. So the next statement here is going to be an if statement, and we're going to do if found neighbor does not equal null, and the end list contains the found neighbor is not true, then we will add it to the list. So I hope I said that correctly. But anyways, so what we're going to do is do the not equals first. So we're going to go ahead and drag in the found neighbor does not equal null, and then we'll get an and statement, and the end list. So we'll need a list of game objects contains, or list.contains. There's our and. Kind of doing this a little bit backwards here. There we go. Get that out of the way. Alright, now we need the list.contains. And that will not equal. There, you know, so not. now our list.contains. Let's see if we can find that. It's under the list, and then it should be contains. There we go. Plug those two pins in that way, and then the output plugs into the NOT. So if that is true, we will add the found neighbor to the enlist, or do a list.add for the enlist variable. So we need to find the list.add, and then plug in the enlist as the instance, and plug in found neighbor as the item. And that wraps up the find neighbors method. So we can do the compile here, and we can see what the code looks like. We can also use the preview tab, and that'll give us a pretty good ballpark of what the code looks like as well, and it doesn't have to compile. So that is kind of handy. May want to just open up each of the prefabs and make sure that the game tiles script is attached to each of the tile game objects. So I was trying to use the uNode runtime, but I changed that, so I'm going to go ahead and swap this out with the game tile script. And that looks good there. And then we'll need to do that with each of the prefabs, just open them up. Again, I was using the uNode spawner here in this particular case, so I'm going to remove that and add the C# script. For me, the uNode spawner didn't show the data I was hoping. I don't know if it was something I was doing wrong, but I haven't used much of the uNode spawner or runtime much, so I might have been doing them incorrectly. So now that each of those prefabs are set up, we'll go ahead and remove them from the scene and go ahead and click Run. We should get some neighbors here, so let's see how that looks. So the neighbors of each tile, so we do have that coordinates right there, but nothing is showing up as a neighbor, so we need to go fix a couple of things. Alright, the first thing we need to fix is that mesh render I was mentioning earlier, where it has get component. That's just plain wrong. So we're going to go ahead and get the component temporary type, and then select mesh renderer, and then select. And that looks better. So we need to delete the other one and swap it out with that, and we will copy and paste that, or just go ahead and search for it again. But there we go. And this is in the show geometry method. There we go. We'll fix that up. Good. So that's the first fix we need to do. Let's see, there might have been something else. So in here I had put in additional spaces, and there should be no spaces in that slash in the string builder. If you put any spaces in there, don't do that. And the index for the get child should be 0. And make sure that this is selected. I found it easier to do that because like I mentioned earlier in the tutorial, sometimes even though it says this, it uses base instead, and those sometimes do two different things. So we'll go ahead and try this again. See if we can get our neighbors. There's 2 neighbors for that guy. There's 4 neighbors for that guy. That looks correct. Alright, that's good. And then all of them should have neighbors. The last one. So there's a small error there. Notice that a few of them are missing a few neighbors. So there might be some additional modifications we need to do. So what I can do is maybe I'll try the square or cube and see if it helps me identify where that issue is. Is it with the hex logic or the cube logic, or is it kind of happening with both of the objects? Might help narrow down the focus a little bit. So let's go ahead and uncheck the is hex and then drag in the square prefab and see if our there's 3, that looks good. There's 5, that's good. I think the square probably looks pretty good. So I think that's just around the hex object that we need to review. So in the start method of the game manager, we need to go down and look at what I'm calling the green section, or the pointy hex section. And we need to remove this negate. That was one too many negatives there. I think that should do it on the bottom vector 2. Now we'll go ahead and select is hex, drag in the pointy hex, and see if we get the correct neighbors now. And we should. That looks better. Alright, that wraps up part 5 of the Hex and Cube map generation using uNode. Appreciate your time, and please come back and visit for part 6 and the final episode of this series. Thank you.